So much, Shiv. This is a tough act to follow. Translation, and that's the subject that we are going to be talking about, was like your singing. For much of the North Indians, people who don't understand Tamil, translation equivalent is fascinating, just like your singing was. But we didn't understand a word. And many of us around here are trying to get our heads around on what is translation, what does it take to actually convert so much science that is beginning to happen in the country into commercializable ventures. And we've got a fascinating panel here, some of the who's who of the deep tech incubation and startup ecosystem. Professor, you were making some fantastic points in the earlier panel where you touched upon so much publication that is happening, so many patents that are happening, and at the other end, there are need to create a lot more startups, and you've been an entrepreneur yourselves. What are some of the interventions that you feel are required today? And we talked about the Marwadi in residence or a Bansal in residence program that most of our institutions should set up. But what else can the institutions do, according to you, to translate more enterprises, increase the throughput of what is being created in the labs into commercial ventures?
Thank you. Whatever I am talking about, I have also done that in the two institutions that I headed. One is reforming our PhD programs. The PhD programs today, are basically producing university professors. Other than that, they are really not doing anything of any other value for any other thing rather. So I think how do we transform or reform the PhD programs? In BITS Pilani, right, in about a year ago, we launched a program called a PhD as a pathway for startup, a deep tech startup. So what we said was, there are so many faculty working on research. So we said any faculty member with a TRL 3-4 kind of stages, can admit a student and jointly work together and then start a company by end of the PhD students, PhD program. Or if somebody has an idea in one of the deep tech areas, can come to us. We will provide them funding, 10 lakh rupees for the startup to start with, or a prototype to start with, and then work on your startup, but along the way get your PhD too. So that was what we started. We were able to generate about funding for about 20 such fellowships, because we were also paying 50% more stipend compared to regular PhD students. We received 1,300 applications for 20 positions. That is the hunger that exists today. If somebody wants to do a startup in quantum area, right, you can't really do that, with a BTech kind of an understanding. So I think there can we pursue some of these PhD ideas as pathways to the doing an entrepreneurship. That program is hugely successful, but we need to scale it at the national level. I mean, not all PhD programs need to be, producing university professors. I think that's where ENRF, I've also been talking to him, so I think I need to submit a proposal on that. But I think these are the things that every institute needs to create those PhD programs. And also, we need to, incentivize our undergrads to pursue higher education. The biggest challenge in this country today is our top students, right? Those who go to IITs or BITS Pilani kind of institutions are not pursuing higher education. In any of our top institutes, less than 5% of students are going for masters and PhD. Everybody wants to do with their BTech, kind of an understanding. With a BTech, the only thing you can do is some business innovation, right? Some aggregation model, and anything else will require deeper understanding of a certain area. So that is another problem. And as a result, while so many new technology domains have come about after IT, right? There was biotechnology revolution, there was nanotechnology mission, there was AI mission, there is, quantum technology mission. But where are the startups in all those areas, right? We are still stuck with IT. And that's where so much of innovation has happened. So many companies have got started. So many jobs are available. As a result, everybody wants to do only computer science, right? Because that is the only place where we have been able to create wealth, right, out of all of these startups. So therefore, that's where the jobs are. That's where the high salaries are. The whole country only doing IT and CS kind of a thing is actually hampering our potential to do anything great in nanotechnology, in quantum technology, in any other areas. I think that is where we need to put a lot of efforts now to create more wealth out of whatever we are doing in academic institutions. So all these missions, right? That government of India doing, like whether it's quantum mission, AI mission, must also support startups, which is beginning to happen. Until 3 years ago, government money going to a private entity was a complete no-no, right? Nobody could have done that. And but now, it's slowly government is saying you can also take funding from the government. And the quantum mission supported something like 10 startups, quantum startups, up to 10 crores, 20 crores kind of a money. I think that has begun now, but these are the things we should have done 20 years ago, right? I think better late than never. At least we are now beginning to do that. Once we create jobs in these areas, then there will be more jobs. I think there will be more students pursuing these as careers, and then more can happen like what happened in the IT sector.
Satya, you've been involved with IIT Madras with a lot of different interventions that IIT Madras has done over the years, and we had Pranit, who's been through the process. I'm proud to be an IIT Madras alum as well. What has IIT Madras done so differently that the throughput coming out of IIT Madras is increasing significantly? And I also know that almost 100 out of 700 odd faculty members at IIT Madras are now entrepreneurs. Is it about incentives? Is it about more flexibility, freedom? Give us the IIT Madras playbook and what has been done differently there.
Sure. I think Professor Rao mentioned it quite well, that we need to convert research to startups. That's one thing that started way back in IIT Madras. It's even before the whole entrepreneurship as a culture even started. The Tenet Lab, which was the telecommunication network lab, in all sense, that was one of the forerunning institutions that created multiple networking startups. They were pioneering in implementing certain things. So there's also this culture of implementation. So they were partnering with the government to do wireless local loops, though it was in a specific domain. So that whole culture was there. And that was, in a sense, an earlier precursor to figure out how faculty can do stuff. So while there is, yes, emphasis on publications, papers, and your metrics are driven towards those numbers, becoming an associate professor and all, but there is this parallel culture that kind of developed, which resulted in organizations like the Research Park, which made that into an explicit outcome. So where faculty members could potentially take a sabbatical for up to 3 years and even beyond, maybe even 5-6 years, to launch and work on a startup. Another activity that also created, and Pranath and a lot of people from that group, Prabhu and Krishnan Balasubramanian, those kind of group, where they created some kind of a consortia model where you could potentially look at B.Techs who could be hustlers, who are really energetic, who get things done, business models and all. Then the masters and PhD students who could work on the science. A combination of these 2 or 3 sets of people working together created the deep science ecosystem, where you could take something that's being done in the lab as obscure as waveguide ultrasounds and convert it to a product that is now sold to who's who in the oil industry across the world. So that's an example, and I think some of those ventures have been supported by IIMA ventures as well. Now, what we attempted to do is to put all of these things together. There is this tinkering and research that happens. There is, at the other end of the spectrum, an incubation cell which was set up to commercialize these ventures. So in between, we started encouraging a lot more activity called the pre-incubation. So what is pre-incubation? Essentially, somebody who is ready with an idea but not yet ready to go out in the market, can we support them a lot more providing scholarships. For IIT students, one of the most important activities is placement. So if you can guarantee placements even after you fail in your startups, many of them try. So that's another area. And the third thing is our IP licensing also became a lot more attractive. So essentially, any startup coming out of any research on IITM gets almost a free exclusive license for a period of 5 years. And if you fail to commercialize, it reverts to the pool. And there was also parallel enforcement and encouragement on patenting as a measure to show progress in innovation beyond that. And finally, all of them also being counted towards academic progress. So when I go for a promotion right now, I also list how many startups I have supported or how many startups I have created, and it's actively being asked. So this whole culture of asking, and exemplars like Krishnan Balasubramanian, Satya Chakravarti, and so on and so forth, thinking that you could take something as deep as combustion in NCCRD and make a venture which is now worth $500 million, which kind of creates that mindset. And it also creates a culture, right? When you want to do software, you go to Bangalore. Now, when you want to do hardware, deep tech, you go to IIT Madras. So we get people from IIT Delhi and other places come and be a part of this ecosystem because they feel that's the culture that's being set.
It's very interesting that one of the targets, and Satya heads the School of Entrepreneurship at IIT Madras, and one of the targets that he told me, and I hope it's okay to share with the wider crowd here, is that the goal set for him by Professor Kamakoti, who's the director, is to produce one IPO a month by 2033. So it's not the publications, it's not the patents that people are thinking about. People are thinking about producing an IPO a month, and people thinking 7, 8, 10 years ahead and saying, how do we convert India into a high throughput, not just at the source, but actually making companies of consequence and getting them public. So fascinating. One of the things, Shell, I want to come to you as a private sector player who's been very actively looking at academic institutions, students, recent graduates. How do you look at ventures, especially in the AI space? Because there'll be a lot of stuff which will happen on the application side. But do you think that Indian academia is doing fundamental research which can very easily be commercialized and funded through a program that you guys are running?
Sure, Kunal. So we run an accelerator based out of Delhi. It's called Invention Engine, and we are primarily looking at the 0 to 1 ideas. And in our last 3 to 4 years journey, what we have seen is most of the application related ideas come from people who are already working. And it's very obvious to think, right? Because you can't expect a final year student to actually create an interview preparation app. They do, by the way, but the point is they have never interviewed, so they don't even know the pain points of a recruiter. Or for them to create a sales tool, because they have never done sales themselves. They end up creating those, but they fail miserably. But for somebody who is 2-3 years experience, it's obvious for them because they start picking up the use cases. Now the dichotomy is that people who are in the colleges are very good in, as people were talking in the first panel, the first principle thinking. They are asking the basic questions. They are working on foundational models and really cutting edge things. But they have no idea of what the market actually demands. But on the other hand, people who actually enter into workforce and work for 3-4 years start getting inundated by so many problems in the workspace and so on, that they start picking up the low hanging fruits, and then they forget about the ones which really matter. So what we are trying to say is that we are trying to bridge this gap from the campus to the startup world. And this is a more personal journey for me, because when I was graduating in 2006 from NSIT in Delhi, I also had a startup idea, but I did not have this sort of an ecosystem back then. And of course, I thought maybe doing an MBA is the right decision. In hindsight, it wasn't. But now, given that where I am, if I can help the undergraduates or people in the engineering college to bridge this gap, and the way we are doing it is, what we do is we've created a customer advisory board, which is people who are in the US. Because for most of the startups, their solution is they're trying to sell to the US or European market or Singapore, etc. But they have no access to these people. So what we have created is a panel of around 40-50 people who are sitting in big companies like Salesforce, Amazon's, Meta, and so on. And who are in the previous panel also, there was a discussion about specialization of areas, right? So what we are doing is, if you are building something in HR, or if you're thinking that you want to build something in HR, we will connect you to somebody who is working in a good company in HR domain. If you're working something in sales, if you're trying to do something in manufacturing and so on, we will try to connect you to people, and then we create a bond. So to Professor Rao's idea that how do you create institutional pathways, this is our small effort, and we have seen immense success, because now we can have people in the campus and somebody who is 10, 15, 20 years experience. And by the way, it's not very difficult to find these people, because many of the people who are in the US also have this FOMO that something is happening in India and they want to be associated. So it's actually, they do it pro bono, right? Of course, they have a vested interest that they eventually might invest in those companies also. That's also good for the startup. So that is one way we are seeing that, there are companies who are in the campus, trying to connect them to. So if you find good talent who is working on foundational things, but marry them with somebody who understands the application side, then you have a match. And that is our thesis. And now we have raised our stake, and we are giving up to 1 CR to each of the startups we are taking. We position ourselves as the Y Combinator in India, and yeah, we will see how it goes.
It's fascinating. A lot of us tend to lay a lot of emphasis on experience. And what I heard you say is experience can also be a negative, because you start thinking of lower hanging fruits rather than building deep expertise in areas. And therefore, being in an academic setup, trying to build or trying to leverage the technology infrastructure there, technology prowess that sits there, can actually help you build businesses which will have deeper moats in terms of intellectual property versus those who are already out and trying to build the application. Very interesting. Dr. Premnath, I want to come to you. We've been talking about deep tech a little bit. So Dr. Premnath is a scientist, and Dr. Premnath, if I'm not wrong, some of your work has been commercialized and gets used across industries. So maybe you touch upon that, because I'm forgetting what exactly did you have licensed out. But unlike deep tech, deep science is even harder. It requires us to have access to specialized equipment, specialized skill sets. And the previous panel, we were talking about how we need to create thematic interventions. How is CSIR thinking about it, which is the Council of Scientific and Industrial Research? How has NCL thought about it? And what are you seeing in the Pune context? I mean, Pune has been one of those great, almost hidden gems. While people talk about Bangalore, Pune has been doing a lot of interesting work. So talk a little bit about what are you seeing in deep science domain, especially in CSIR in Pune context?
First of all, just a little bit about, since you mentioned it, my interest has always been in product development and seeing products in the market. And I was lucky that some of my work, early work, today is used in with a benchmark material in some of the hip and knee joint materials that you see is implanted in more than 1 million patients today. That's great for it to happen. We tried doing more of that, trying to do many more of that. And my next set of things were relating to craniomaxillofacial implants. I work with implants basically. And we were successful there as well. We licensed stuff. And it is now implanted in several thousand patients. It's a more niche kind of a application. But the struggle was, it was a large struggle, right? Taking it to market. And I sort of appreciated the fact that the ecosystem really matters. If you want to take anything which has depth, and you need a richer ecosystem to make it happen. And that's where, my thinking behind what we are doing today began. The other thing which I must emphasize is that the entrepreneur matters a lot. Okay, it's sometimes we overemphasize the scientist and the professor and the technical lead, but it's the entrepreneur, the person who champions the idea and its market introduction is, I think, very important. And this happens also when you license technology, because there has to be a person on the other side who says that they want to bet on it and take it ahead. And if you have done any licensing, you'll know how important that person is, right? In the companies and so on and so forth. By the way, even if you're doing an acquisition, it's the same thing, because the large company has to have a champion on the other side who bets on a given startup, right? In the startup world, it's the entrepreneur, and I distinguish it from the technical lead and so on and so forth. And one must understand that is one of the biggest bottlenecks for us if you're thinking of deep tech entrepreneurship. Okay. In the IT world, we are fortunate. We have a lot of entrepreneurs who have done it, grown, built businesses, and are looking at the next opportunity. There's some experience there. There are people who have worked in those environments, seen entrepreneurial companies. So there's of a certain kind, and so there's some pool available. In the deep tech domain, that pool is a weakness for us in the country, right? We don't have that pool. So one of our key things should be to find opportunities to marry good science with good entrepreneurs and good money, right? And in the very beginning, if you want to really build on it, right, I'm very convinced that the money has to be a grant and nothing else. Okay, that is, I think, has been the recipe for success even in the US. Okay, and one needs to push that button as much as possible. Question is, how do we get those entrepreneurs, right? Unfortunately, the Bansals and so on of the world may not qualify there. Okay, uh, I, they have they have the mindset, they have the drive, right? But they don't necessarily have what it takes to necessarily see technology development and de-risking over many years, right? And that requires a different level of patience. And this patience is not just something to do with people, it's also got to do with your environment. For example, if you have an environment where there are a lot of opportunities to make a lot of quick money fast, right, it's very difficult to convince somebody to enter a domain where you have to take so many years with so much risk to make money, right? So it's very contextual, right? In some of the countries like US, it thrives because they have run out of opportunities where they can make quick money, unlike China and India, right? Here we can still do that. So we are up against a difficult problem over there. I also want to point out that, see, all said and done, if you look at all the successful companies coming out of all the institutions, there are very few which are actually scientist led. Okay, that's honest truth. Okay, or professor led, right? So it's the entrepreneur who matters a lot, and we need to focus on that. And there are also very few who are PhD students who have converted into startups, right? So you need to ask the problem, what's the real issue over there, right? So when we started looking at it, my first goal was just to build an ecosystem out where people who want to do it can flourish. And I've always believed that it's the strength of the ecosystem that decides the ambition of the entrepreneur, right? If you have a very weak ecosystem, people tend to work within those means to achieve what they can, right? If you have a rich ecosystem, people tend to take more risks within that ecosystem, right? And that's quite important as well. Also, role models matter, right? People who have done that and seen that. So in the very beginning, in NCL, I spent several years just bringing role models of people who have done it, uh, to show that that is also something that you can be proud about. It's not just being a Cambridge Don, with a Bhatnagar and so on and so forth, to show you can actually have the satisfaction of seeing a product in the market, seeing people benefit from it, right? And that's also a certain kind of a joy for people in science. See, all said and done, the most academic of professors also want to see their science in use. The worst thing they the worst thing they want to see is nobody even picking up a paper that they wrote and reading it. Okay, so let's face it, right? They want to see it in use, be it for science or for products, right? So that is something which we have to hit home. I'll just still close with a example. So if you look at the mRNA vaccine example, which is one of my favorite examples, I just want to point out a few things which you should learn from, and I consider that a recent deep tech development which we should be looking at. So the work which led to the Nobel Prize a few years back for Carrico and Weizmann was something which was done in 2005. Okay, and they were essentially just modifying the mRNA to evade the human immune system. And it's a discovery. It's actually invention because they modified it, right? That they could do this, and that mRNA could evade the immune system and do something useful in the human body. And many of you know Carrico didn't even get a position in academia at that time. Okay? The people who employed her, right, were the founders of BeyondTech, right? Two scientist entrepreneurs, clinician entrepreneurs also, who took the bet. Here I want to point out, somebody had to first see the vision that this is possible with mRNA technology, right? Do you think an average person who's not trained in science could have seen the vision of that? That with mRNA, I could create a factory for proteins in the human body. It's not possible. So you cannot even have an average undergraduate envision that. So it's that vision that one creates, which our students and people have to see, right? And be able to say, this is possible, and that's what we want to build. The second thing is, when that happened and somebody married it with other pieces of technology, which was the lipid nanoparticles, and thought about a vaccine, right? They thought about other things as well, by the way. And those two people took the plunge. They were not the scientists who originated the Nobel Prize winning work, okay? But they hired that person. They bet on that person when others didn't. University of Pennsylvania did not, right? Those people matter, okay? And they went on to build BioNTech 2008 till 2020. They were struggling, but there were people who were investing money, right? So investors mattered because they thought there was something big that could come out if the success is there. So high risk, high reward was an option there, right? And 2020 happened, and today BioNTech is $1 billion company, right? Well, Carrico and Weissman got the Nobel Prize. They were millionaires. These guys are the billionaires. But that said, both matter, right? So how do we create those are the question for us. Now, the deep science part, CSIR till some time back was the largest investor in many ways in non-strategic science, right? And the output was also there in that sense. Some was getting converted into tech transfer, so on, but our ecosystem was not really taking it up the way one would expect that to happen. So we were looking for other ways, and that's how it began. I'm really optimistic about how ANRF kind of things is really building depth in the system, because without that you just cannot build anything which will be pioneering. You'll always be following. And I don't consider use of tech as deep tech, okay? It has to be tech development. There has to be vision about the future. There has to be some novelty in it, right?
Very interesting. Thank you so much, Dr. Premnath. What's interesting to hear here also is that very often the scientists will not necessarily be the innovators will not be the entrepreneurs, and we need to make this matchmaking happen. A very interesting example of a company that we've had the fortune of backing, which came out of the work that Dr. Premnath does at Venture Center, is a company called Nayam. Now, Nayam Innovations is a very interesting intraocular lens that has been designed. And this is actually yet another Marwadi, right? Who's actually going, an IIT Bombay alum, who's gone into NCL research labs. He's identified through the NCL process a scientist who was sitting at Caltech or University of California, Berkeley. Now I'm at Caltech. And an NCL scientist, brought them together, created a company called Nayam Innovations, which globally for the first time, they're actually creating intraocular lenses, which can be, once put into your eye, the properties of the intraocular lens can be changed once the lens has been put in, modified, so that you get the exact, most accurate eyesight. And this is globally game-changing. And coming right out of our labs, some phenomenal work that is happening in the Indian research institutions. And many of us who are investors need to be willing to go deep into Indian academia, identify these innovations. Taslim, I want to come to you sitting in the middle of Bangalore, buzzing with all the internet, e-commerce, this, that. You've been doing some outstanding work in a sector which is, as difficult as Alapayothe for me to understand, but fascinating work that you've been doing. What does it take for us to create more C camps, more thematic interventions in the country? Because that's the need of the hour. And what does it take for us to have 100x more entrepreneurs taking the path to solving some of the problems in deep science, like what the entrepreneurs that you back?
Thanks, Kunal. Great to be here. Just to possibly, I think I have 20 odd minutes, so I can go. So, no, but just to possibly begin, so just to give you a background, not everyone would know CCAM. So, CCAM is Center for Cellular, Molecular Platforms, an initiative supported by Department of Biotechnology, Government of India. setting out of Bangalore in what we call it as a Bangalore Life Science Cluster. Along with CCAM, we have NCBS there, National Center of Biological Sciences, INSTEM, Institute for Stem Cell Medicine, and TIGS, Tata Institute for Genetics and Society. All four together, we form possibly India's largest life science research campus, and also a phenomenal environment, and something that kind of I'll elaborate onto, where fundamental research, translation, innovation, and then society connection happens from a research lens. And that is a very, very strong environment that has been created, and we are very excited about it. Much more to do, nothing that is complete and perfect, but I think we would like to build on that. That actually, we have nearly 2,000 people on campus doing this really good work, almost 800 to 1,000 PhDs working there, nearly 300, 400 postdocs, and now nearly almost 400 entrepreneurial scientists who are there. So this is really a solid campus which has happened, and that is something. If you heard the first panel carefully, I just want to take some of the points which are built in, which are very, very important. For deep science work, you require critical mass of excellence being done together, right? It cannot be done in silo one step. You need that environment, a conducive environment, which constantly kind of provides you an upliftment of thought process, which you can go and build on it. And that's very, very important. We need to build places where different institutions work together without having borders, without having real issues of egos and other things. And you actually have a lot of movement of people, because it's people at the center of everything. As long as you allow people to collide with each other, and if people are capable, I think good things can happen. And that, so CCAM benefits by being part of that, and take some of the thoughts forward by taking it forward. I just wanted to, if you allow me a couple of minutes, I'm fast forwarding at the same time. So CCAM supports a lot of deep science innovations. We have now supported nearly 600 odd companies in deep science. So largely it is in healthcare, agri, and environment. So it's all life sciences, biological sciences. So we are a life science, biological science organization. And we have nearly now 100 products in market, including 15 US FDA approved products now in total across different capabilities. So a lot of good knowledge has happened over time. And we are hoping that some of our blockbuster capabilities, which are coming in broad spectrum antibiotic, and tomorrow I have a panel with Anand here, some in cancer, some in medical devices, and so on. And we have products now in Europe, Africa, US, UK, NHS, all that. So good things are happening. One of the thing, and I just wanted to go back to and building that, one of the thing, and we have actually observed, is that weakness is that we haven't had strong academic sciences come to that fore in that proportion that we would like to do. We are trying hard, but I think it hasn't happened, and there are many reasons to do that. Think about it. We are investing possibly 20,000, 30,000 crores only in scientific agencies every year, right? Across all, if you just put together, and you still do not have the good, amazing, every year 10 top breakthrough scientists who actually are building new stuff. That is small gap. And one of the reasons is that you cannot, as Professor Rao said, and I'm going to point out 3 or 4 pointers from the first panel, so I hope you were listening at that time. Not every academic scientist needn't be actually an entrepreneur, right? But science is amazing. So what do? You can't just say, hey, come on, man, you got to go and do it, man. You're amazing science. You can't do that. What you need to do is to say, your science is amazing. The challenge is that you believe that possibly right now industry should take it, but your science is deep science. Hence, it is very risky, and hence industry cannot take it today. There's a difference between what industry wants and what is academia can give in this particular sense. So there's a gap. There's an early stage they want it, late stage they want de-risked. But you can't say, no, you keep on doing it. And this happened, to be honest, from realization. I'll try to be quick. One of the amazing signs that when I came back after my return, and I saw a group, Satyajit Mayer of NCBS, Shahid Jamil of ICGB, Satyajit Rath of NII, top class scientists. I don't think I have seen such great collaboration. An immunologist, a virologist, and cell biologist work together and published a bunch of papers summarizing how HIV invades our cells, immune cells, and hides inside it and make every cell infected. But once it hides, it takes away the recognition by rest of the immune system that it is infected. It just takes the soldiers on our cells inside. But the best understanding of HIV makes us immunocompromised because it is inside, it is not. Now think of it, if really amazing science, best publications. But when I went and I said, this has to go out, and I talked to Gilead people who were right there when I happened to be in San Francisco and so on. And it happened multiple times. They'll put a hand on your shoulder and say, this is amazing science, Taslim, but this is not ready. I can't take it to my CSO. You have to do A, B, C, D, E. And when you come back to me, I'm going to take. But I love this science. Now, I can't ask Sajid Mir, I can't ask Shahid Jamil, I can't ask why do you do it? So I literally scratched, I'm not kidding, literally scratched my head for months together. I said, what is the route out? How does this amazing science go out? And finally, we said, we got to do something. We have to build what Professor Rao said, an institutional pathway which can take these amazing academic discoveries, which actually are really demanding to be going out, but not ready today, to translate and do this A, B, C, D, E that industry asks to be validated, make it industry ready, and actually hand it over to industry. Without that, amazing science will stay in academia. And that was a very important thing. We realized over time, but that is the thesis that we built, and built a program called Discovery to Innovation Accelerator. The motto was simple: starts where academia stops and stops where industry starts. It was right the bridge that we wanted to build. Over last now 7 to 8 years, we have built the pathway. It is right now being supported by Office of PSA. It is supported by Chris Gopal Krishna's Pratiksha Trust, another Bombay philanthropy, where we are constantly doing the national call, pulling amazing scientists from DBT, CSIR, DAE, all other agencies who are really good, assessing the novelty, going to industry saying that, brother, sister, whatever you call, brethren, right? And do you think this is good? And if you think this is good, you would like to tell me what is your ABC. So this is called industry-centric translation, which actually is not your own gut feeling that you could do that. We have now over time, now we have licensed now 9 technologies like this, including internationally. One of the amazing work from ILS Bhubaneswar to IBSD Imphal to IHBT Palampur to IPR here, Gandhinagar to NCBS. We have done it. These technologies are being licensed out, and that is important because there were no. So we have made a national pathway, in a way, translation platform, which can pull these things and take it to the next level, and that is very, very important because that's what is. I think what you heard from Pranit in the saying, you need for deep science a critical mass. What you need is institutional pathway, and you need focus of theme like biosciences or life sciences, where you actually could do that. And that is very, very important. So to be able for us to do it, I'm answering a question in a minute now, we need to have a thematic, places of excellence. I've been saying it for a while. We cannot distribute. So, we need thematic areas where say, if you need to do this, this is the place you go and these things will happen. You need to have identified top 5, top 10 thematic areas, build center of excellence is not a small program, but absolutely a campuses of that large, and then make things happen there, which is very, very important. I think the injection of ANRF and RDIF is actually suddenly, shaken up the system. Everyone wants to do something together. And this is the right time for us to, I think, weave some of the other dots which have been around and build on that.
So one of the things that the entire group that is sitting here is trying to do is set up a collaborative platform through which we will actually create thematic interventions. It's going to be unveiled later in the day. Create deep interventions in each of these thematic areas, whether biosciences, whether decarbonization, bring the institutional know-how together and provide whatever it takes to actually create the critical mass in each of these sectors, because these can't be scattered shots. There needs to be clustering happening. There needs to be the ability to learn from each other's experience. And we look forward to having a discussion on that. So one of the things that you talked about, and I'm a little conscious of time, but very quickly we'll go around. capital. You talked about Lakshmi and Saraswati don't necessarily sit together, but at the same time, we are seeing models elsewhere in the world. I mean, MIT has Engine, Stanford has tried doing it, and most universities that are setting up spin-out funds today. Should capital be actually going and sitting deep into our IITs, BITS, and academic institutions?
I think it has to happen, and I think we need a Flipkart of deep tech right now. No, that one Flipkart has created 300 great kind of companies. Many of them are also unicorns. I think we need that moment, that Flipkart of deep tech. Indian science and technology ecosystem also needs to be fixed. Right, at the end of the day, we are not spending enough money. In fact, the quote that is now talked about is Indian science and technology's African budgets, US ambitions, Russian methods, Chinese opacity, and Indian petty politics. That is what that is what India's science and technology ecosystem is. I think that needs to be fixed first. And I think that's where ANRF is. Somebody like him heading it were unthinkable 5 years ago. So you couldn't have got him into the government system. So I think hopefully things are getting fixed now. But I think also another thing we need to do at the national level is more grand challenge kind of an approach, which even ANRF hasn't started doing it because it doesn't have people who can write those white papers, right? Can we pose 5 grand challenges of this country, right? Make it as a challenge, let institutions compete with each other, right? Create those multidisciplinary teams. Any deep tech enterprise requires a multidisciplinary approach. In India, in electrical engineering, where I come from, a microelectronics person would not work with a power electronics person. Now, how do we bring these two people together? I think the problems need to be now posed nationally, right? Then people form groups, academic within the institute or across the institutes, and then submit proposals to solve that problem. And the overlap is a big problem, as you said, but that cannot happen. I mean, here you have to fund 4 groups to solve the same problem, right? They might follow a different approach, but if one of them succeeds, then you would have solved that problem for the country. India has all the problems of the world. If you are looking for a problem, you don't have to go to an American journal and look at anything, right? So I think we need to take this grand challenge kind of an approach, help multidisciplinary groups to be incubated, and then start solving these problems. I think that process, in my mind, will result in many more deep tech kind of startups.
Taslim, if Shiv was to give you 2,000 crores, since you don't want us to be talking smaller numbers, Shiv, and this is a question for all of you. What are the big interventions that you would want to make to increase the throughput of your work? And this is a question to each one of you. And each one of you, Shiv, has written a 1,000 crore check.
So I think she has already promised that. But no, I think one of the very important thing I said, I think would be, I strongly believe, not for CCAM, but for India, would be translation piece. It is very, very important space we need to have, because eventually industrial knowledge based or early stage knowledge based innovation will kind of go out. We need the milk to come from the bottom up, and science based translation has to happen. And I think initiative like H3, which is very, very exciting, is very important. One thing that would be very, 2 quick things, I would say public health. Innovations that actually address public health largely for India, very, very important, like MNCH and many other things. And I think the second component would be agriculture. Agriculture hasn't seen, while some of the work we have talked about, but completely, transformative, the innovations per se. And that is much required in the spaces. And I think a dedicated effort in those components with multidisciplinary approach, perfectly good, would be something as a country we would definitely be virtually.
Satya, you've been given 1,000 crores. What are you going to do with it? In the context of IIT Madras. Yeah. Okay, 2,000. All right. I was keeping the remaining 1,000 with me.
No, certainly 1,000, 2,000 and more certainly can be consumed given this large translational gap that exists. So one thought process I've been also talking to Kunal about is to set something up called as a translational research economic zones. Like the SEZs have been quite successful in promoting exports, and given this clusters that are forming in different centers, make the cluster come together and set up an economic zone with a physical infrastructure. Because one of the challenge in many of the deep tech translation that we do is the capital intensity. A lot of capital needs to be invested even before you can start making prototypes, be it infrastructure for testing, be it infrastructure for analytical instrumentation, and even certification. Like many of our startups build cells, electrolyte cells, and all of that to go get it tested, certified, validated. Again, needs a lot of infrastructure, which venture capital money will not put in. I mean, they are not going to support building equipment and test infrastructure. So that has to come from such a large center, which has the credibility and likely to be anchored by a group of academic institutions that has an expertise. As a small experiment, we did try setting up an energy consortium at IIT Madras. We have multiple industries contribute membership funding, and the Institute of Eminence grant that was given to a bunch of institutions, we had internally utilized it to set up this consortium. In that, we also realized the problem of not all faculty are going to translate. And even if they do, they probably will address the 0 to 1 problem where they get some revenue. But then to get to an IPO a month, we need the 1 to 100 and the 100 to 1000 problem solved, which really requires entrepreneurs. So we are trying to look at a venture building kind of a model. We bring everybody together. The innovator remains an innovator. There is a win for him because he is owning or she is owning like a 3 to 5% equity, which gets liquidated at a later stage and continue to do great academic work, and all the grants and everything goes back to the lab. And a win for the entrepreneur because there is a really validated science which has now grown to a technology. With the presence of all of these industries, there is also a market and then the fund that is being available. So it's actually the full ecosystem that's being there. And in the translational economic zones, what we want to do is also bring everybody together, because one challenge that we realize in doing this, we like it or not, a lot of components that we need has to be imported with neighbors that have land borders. And if it takes 9 months to import something with all the process, I think you may give me the money in 2 months, but I can't spend the money in 9 months. So that's a real bottleneck. So create these structures where you pretty much say you don't have to wait for anything. You just go at the speed at which you can receive the money and spend it. And also get rid of multiple of these taxes so that your $1 can be $1.4, $1.5. And we are start for research funding. So create those incentives where not just startups, not just researchers, but even large companies are willing to come and do their research, because that allows us to create that ecosystem where tier 1 institutions set up all of these infrastructure, but then we also need human capital, more PhD students. Our PhD recruitments are way abysmal and not many people are joining. So create that incentive for more people to come and join, so that each of those cities, C Camp in Bangalore or a Decarb hub in Chennai, whatever that may be, that will be created. And your 2000 crore, I think, is like Shark Tank. That's what I will do.
Very interesting. Thank you so much. Our time is up. It's been a fascinating conversation. All of us are trying to come together and bridge some of the gaps that exist between translation of science into commercially viable ventures. I'm reminded of a very interesting essay that Paul Graham had written, who's the founder of Y Combinator, several years back. And he talks about what does it take for you to create Silicon Valleys. And he actually talks about 3 important ingredients that go into creating a Silicon Valley. The first one, he says, is what you need is nerds, the geeks, and the entrepreneurs, the students, the researchers, all are in that category. The second that you need is actually the believers, and believers will take the form of the early adopter, sometimes the government who's willing to procure, sometimes a good Samaritan who's, but also funders. I mean, the investment is a very critical piece, and we need to make that available to our entrepreneurs. And it's fantastic to see that various forms of capital which are being created for the entrepreneurs to access in the deep tech space. The third and the most important thing that is required, and he talks about it, is culture. And it is very good to see that some of India's top academic and research institutions sitting here around the table are actually saying that, hey, we are proactively changing the culture from being a patent-driven, a publication-driven culture to a IPO-driven culture or a startup-driven culture. And therefore, I have phenomenal hope in what is going to happen in the country in the coming 2 decades. it's a fantastic opportunity for the entrepreneurs who hitherto have been looking at lower hanging fruits. Here's an opportunity for you to go deep into Indian research laboratories, try identifying the best technologies or best solutions that exist. Sometimes it will take a little longer, but NIIM is a case in point where while it may take a little while for the technology development to happen, but once it sees the light of the day, there's a big bumper gain that is waiting for you. So encouraging all the entrepreneurs, aspiring entrepreneurs to engage deeply with our academic ecosystem, and we are hoping together we can build an innovation nation. That's the need of the hour for us, and look forward to closely engaging with all of you. Thank you so much again. Sorry, we don't have time for Q&A. All the Marwadis here can write to Riva. You'll be top of our list to be considered for entrepreneur scientist matchmaking, but really looking forward to engaging closely in this journey. Thank you so much, everyone, for being a part of the panel.